We're asked to solve this inequality. Now I'm going to start by sketching the function on the left and the function on the right. So the critical point for the function on the left is going to be 2. It's when the modulus kind of kicks in, does its work. So before that, after it, it's going to look like this. It's just your normal x minus 2. But before it would have been negative, but it swaps around because of the modulus. So we get this V shape. I'm going to just add on that this is 2. That's what I mean by the critical point. And then when I put x is 0 in, I'm going to get the modulus of minus 2. This is also going to be 2. Next up, 2x minus 6. Critical point here is when 2x minus 6 is 0. So that's going to be when x is 3. Now this is going to have a steeper gradient because it's 2x minus 6. So I'm just going to illustrate it like this. And we can see immediately there are 2 points of intersection. You can also see from the graph where the x minus 2 is less than or equal to 2x minus 6 because it's this blue curve and it's going to be here. It's lower than the red curve here and here and also this side. It's just that region inside that we're not interested in. And we're going to include the points where they intersect as well. So the method now actually is to find the points of intersection. And like you can do it quite quickly using this method because this first point is just going to be when the modulus is not doing anything to either one. In fact, it's going to be when x is greater than 3. This is the region we're interested in. That's when they're both just going to, basically the modulus just disappears. Greater or equal to 3, I should say. So x minus 2 is going to equal, I'm finding the point of intersection, not the inequality at the moment. X minus 2 is going to equal 2x minus 6. So subtract x, add 6 on, x is going to be 4. Okay, this point here is 4. That all tallies up. And now I've just got this point to find, and it's going to be when the blue, it's going to be in between 2 and 3, I should first of all say. So it's going to be when the blue curve, it was already sort of positive inside, so I just got my x minus 2. But then the red curve, that's when it would have been negative inside the 2x minus 6, but the modulus is going to kick in, so it's going to become minus 2x minus 6. And so it's going to be minus 2x plus 6. Let me give you a little bit more info on that. So if f of x equals the modulus of 2x minus 6, then it's actually going to equal 2x minus 6 when x is greater or equal to 3. And then when x is x is lower than 3, it's going to be negative inside, which means the modulus function makes it negative here, which gives me minus 2x plus 6. So I've just gone straight to it in this equation, but that's a little bit more background info. And that's the nice thing about this sort of, question. You can look at this sort of method, I should say. You can just look at your graphs and identify, these solutions quite quickly. So now I'm going to get 3x equals 8, and therefore x is 8 over 3, that point there. And there's going to be no other points of intersection, so I don't need to solve any other equations. I can just look at the graph, the purple region. Well, we've got x is less than or equal to 8 over 3 for this part here. Or we had this part here, x is greater or equal to 4. All right, that was part A. Okay, on to part B. give full details of a sequence of two transformations needed to transform the graph of y equals the modulus of x minus 2 to the second graph, this one in red. Well, I'm going to call this f of x. And then I've got to think, what am I trying to get to here? I'm trying to get 2x minus 6. Well, a good idea in this sort of question is to first of all deal with the translation. So I'm going to make it f of x minus 4. We replace all of our x's by x minus 4. And that is going to give the modulus. Sorry, one sec. That's going to give the modulus of x minus 6. So this is a translation. Now you can say 4 units in the x direction, or you can write it as a vector by 4, 0. Remember, it's inside, so it's the opposite, and you get 4, 0. Okay, now finally, I want y equals modulus of 2x minus 6. So this is going to become f of 2x minus 4. I'm just replacing x by 2x. And this is also, in the way that I've done it, is it's affecting the x. So it's going to be a stretch. Because I'm times n by 2 inside, it's going to be a stretch of scale factor a half. In the x direction. Parallel to the x-axis, I prefer saying in the x direction. Now, there are lots of other answers, in fact, for part B, so if you didn't get what I got, then that could be absolutely fine. An alternative is to first of all do the stretch by scale factor a half in the x direction. Make that the first transformation that you do. You just have to be a bit careful if you do that, because you would not now do a translation by 4, 0, because when you do a translation by 4, 0, you replace x by x minus 4, and that won't give you the minus 6 overall. So what you would then have to do is replace your x by x minus 2. It would actually be a translation by 2, 0 if you swap the order around. Because now we'd replace x by x minus 2, and we would still get 2x minus 4 minus 2, so you would get 2x minus 6. You could also do a stretch in the y direction, because then you times the whole thing by 2. So it would be 2x minus 2 after this stretch in the y direction, and you can bring that inside the modulus. I'm not writing all of this down, I'm just sort of saying it, but I hope that makes sense. And then you could do a translation by 1, 0, because you put a 1 there and that will still give you the 6 overall. There are other ways. I'm not going to go into any more. I've talked about 3 different ways of doing this question. So as long as you kind of logically do it, and if you're unsure, then check your answer. Like try and use GeoGebra or Desmos or something like that to see if it's working out. Just remember, when you do your stretch in x, you replace x by kx, and the scale factor is 1 over k. And when you do your translation in x, x is replaced by x, well, plus k. That would be a translation by minus k0.